What's up everyone, Patrick here, welcome back. Moving on to the next question. We have to solve and check this linear system over here. So notice we have two lines, got to find out where do they intersect. So we got 3x equals 6 minus 4y. We got 5x minus 3y equals negative 19. So a couple of different strategies we could use. You could do substitution, elimination. What I'm going to do is I'll do elimination. So what I'm going to do is put these in the same format. So notice that the x and y are on one side for this line, but over here we have the x on this side, the y on this side. So I'm going to bring the negative 4y over. So I'll rewrite this as 3x plus 4y equals 6. And then we want to choose whether we want to get rid of the y's or the x's. I'm going to get rid of the x's. So we got to find the lowest common multiple between 3 and 5, which is 15. So what I would do is I would multiply everything here by 3, and then I would multiply everything here by 5. So we would end up with 15x minus 9y equals, over here would be negative 57. Then over here we would multiply everything by 5, so we'd have 15x plus 20y equals 30. And then we're getting rid of the x's, they have the same sign, so we would subtract this from that. So 15x minus 15x would give us 0. Negative 9y minus 20y would give us negative 29y. Right? We distribute that negative to the positive, becomes a negative as well. And negative 57 minus 30 would give us negative 87, like that. And then to get the y, we would divide both sides by negative 29, which would give us positive 3. So y would equal 3. And then we could take that y value and plug it into either original equation and then solve for the corresponding x value. I'm going to do it with this one. So we'll have 3x equals 6 minus 4y. 3x equals 6 minus 4 times 3. 3x equals 6 minus 12. Negative 6. Divide everything by 3, x would be negative 2. So we would have negative 2 and 3. That's the point at which both of these lines intersect. And then if we want to check it, actually before we check it, I actually want to show you as well, you could have done substitution to get these two values. Let me write the x value over here. So another way is you could do substitution. So let's say we isolated for this x, divided everything by 3. We would have 6 equals, 6 divided by 3 is 2 minus 4 over 3y. And then we could plug this in for this x. So we would have 5 times 2 minus 4 over 3y minus 3y equals negative 19. 10 minus 20 over 3y minus 3y equals negative 19. Bring this over. Right? Negative 19 minus 10 is negative 29, and then negative 20 over 3y minus 9 over 3y. If we get a common denominator between these two to make them one expression, we'd end up with negative 29 over 3y. So notice how it's a lot more of a headache in doing substitution. So this is like negative 29 over 1, divide both sides by negative 29 over 3. Which is like multiplying by 3 over negative 29, right? Multiplying by the reciprocal. Negative 29's cancel out, and we end up with y equaling 3. Exact same solution that we got before. So you could have also did substitution, but it's just a bit more of a headache. You're going to be working with more fractions. Now, if we're to check our solution, what we would do is we would write both lines like that. And all we have to do is plug in x equals negative 2, y equals 3, and make sure left side equals right side. So we would have 3 times negative 2 equals 6 minus 4 times 3. This would be negative 6, 6 minus 12. Notice we do indeed get negative 6 on both sides. And over here we'd have 5 times negative 2 minus 3 times 3. Equals negative 19, we'd have negative 10 minus 9. And we do indeed end up getting negative 19 on both sides. So those are the two checks that we do. So we could be pretty confident that that's the correct answer.